Ever wondered how the small devices that make up our world manage to function smoothly without overheating or breaking down? Well, the answer lies in a small but mighty component known as the resistor. These unsung heroes of electronics play a crucial role in every piece of technology that we use daily, from our smartphones to our microwaves, and even the streetlights that guide us home at night. Resistors regulate the flow of electrical current, ensuring that our devices work optimally without burning out. They are the guardians of our electronic world, silently maintaining the balance and ensuring everything runs as it should. Think of resistors as the traffic police of the electrical world. They manage the flow, directing just the right amount of electricity to where it's needed. They are ubiquitous, yet often overlooked in the grand scheme of things. Now, let's delve into the history of these vital components. The history of resistors is as fascinating as their function. Our journey to understand this crucial component takes us back to the 19th century. It was a time when the field of electricity was still in its infancy, and the scientific community was just beginning to understand the fundamental principles that govern it. Enter Georg Ohm, a German physicist and mathematician. Ohm's groundbreaking work in the field of electricity gave us Ohm's law, a fundamental principle that explains how electric current, voltage, and resistance are interconnected. Ohm's law laid the foundation for the development of the first practical resistors. Fast forward to the early 20th century. With the advent of radio technology, the need for a device to control the flow of electricity became apparent. This led to the development of the first practical resistors. These early resistors were wire-wound models, simple yet effective in their design. They consisted of a wire wound around an insulating core, with the wire's resistance to the flow of electricity providing the desired resistance. As the 20th century progressed, so did the design and efficiency of resistors. The wire wound models gave way to carbon composition resistors, which used a mixture of carbon dust and binder to create a range of resistance values. These resistors were cheaper to produce, more durable, and offered greater precision. The evolution of resistors didn't stop there. Today, we see a variety of resistors in our electronics, from film and foil types to the tiny surface mount resistors. Surface mount resistors, or SMDs, are incredibly small and designed for automated assembly, a testament to how far resistor technology has come. Every step of this evolution was driven by our increasing need for smaller, more efficient, and more reliable electronics. It's a testament to human ingenuity and our relentless pursuit of progress. From their humble beginnings, resistors have truly evolved into an essential part of modern electronics. As we move forward, who knows what the next chapter in the story of resistors will look like? One thing's for sure, resistors will continue to play a vital role in the electronics that power our world. So, how do these tiny components manage to control the flow of electricity? Well, the answer lies in a fundamental law of electronics known as Ohm's law. This law states that the current passing through a conductor between 2 points is directly proportional to the voltage across the 2 points. Now, that might sound like a mouthful, but what it essentially means is that if you increase the voltage, the current will increase too. Resistors take advantage of this principle. By introducing resistance, a resistor creates a voltage drop across its terminals. This drop in voltage effectively limits the flow of current. Think of it as a dam on a river. The larger the dam, the more it can control the flow of water. Similarly, the higher the resistance, the more a resistor can control the flow of electricity. In essence, resistors are the traffic controllers of the electronic world. They decide how much current gets through and prevent electrical systems from being overwhelmed by too much power. Now that we understand how resistors work, where exactly do we find them in our daily lives? Well, resistors are everywhere. They play a crucial role in controlling the brightness of lights. By adjusting the resistance, we can determine how much electricity flows through a light bulb, thus changing its brightness. But their role is not limited to lighting alone. Have you ever wondered how radios and televisions manage to stay on the right frequency? It's the resistors. They set the frequency of oscillators in these devices, and that's not all. Resistors are vital components in almost every electronic device we use. They're in our computers, ensuring that the right amount of electricity reaches each part. They're in our cars, keeping electrical systems running smoothly. In fact, resistors are so ubiquitous that it's hard to imagine a world without them. So the next time you use an electronic device, remember the humble resistor, working silently in the background to ensure everything runs smoothly.